Thank you very much for coming to this session about Monolith. I know that nowadays going to a session about Monolith and not microservices is quite strange. And in this session, we're going to see some things that probably are logical, right? I mean, that you said, yeah, I already know this. But I thought that it was really interesting to have all these things in just several slides in the same talk. My name is Alex Soto. I work at Red Hat, and I'm the creator of lordofthejars.com. And well, if you have any question at the end, you will have my email, or not, you can send me a tweet. And also, it seems an irony, right, that I'm the author of testing Java microservices, right? But it's really fun because it was like, I've done Monolith, then I started developing microservices, then I wrote the book, and then I said, okay, maybe Monolith was not bad at all. So, yeah. So, if there is any question, we're going to we're going to see several technologies or maybe let's call it patterns. So you have any question, just raise your hand at that time. I will answer it. And just, I mean, if you want, you can wait until the end, but yeah, you can also do it in the middle. So where this talk comes from? It comes from this tweet from Keltry that says that in 2020 there will be again monolith application, right? And then my college board Soto said that maybe nowadays we are into the trough of dissolution of microservices. So what is a trough of dissolution? Is like when you have tried things, you are developed a project, right, with microservices in this case, and then you said, okay, we've done it, but it was somehow painful, right? Maybe next time I will not do it in that way. And this is summarized in this this graph where you say that first everyone is just saying, yeah, microservices, Netflix is doing microservices, I'm going to do microservices. I want to do microservices because in my curriculum vitae it looks pretty good. And then you see that, oh shit, things was not as easy as you expect. And then the companies that has survived, they're still in the plateau of productivity, and then the others, well, they try to do whatever they can. Even there is this quote about Rebecca Parson, which is a CTO from ThoughtWorks, that says that due to the given burdens of cost and organizational maturity, microservices will likely never reach the adopt phase. Which is something to think about, right? Because if never is going to be at adopt phase, maybe it's not a good thing to just think on doing microservices just because we want to do microservices. So let's start talking about things. The first one is about isolation. One of the great things about microservices is that you have an isolation between services, right? This helps us to not have a lot of spaghetti code, because since the services are split across your cluster and you communicate them with a network, you cannot call an inner method that is inside this other service because there is a network there. And the thing is like, okay, can we try to get something similar but in the monolith? So let's see how we can isolate code in monolith. Of course, you can do it, and there are several strategies. And in this case, I'm going to just show you one, which I think that is the one that worked best for me, but there are others. And it's doing something as simple as this. We just have a project with some modules. This is your build tool module. If you're using Maven or Gradle, you have the module concept. You have my application, which has a game, has reviews, and has details. And then inside of each of these modules, I have another submodule, which is like API, MPL, MPI, MPL, API, MPL. And each of these APIs, MPLs looks like this. The API module is the public part, is how other modules communicate with this module. Expose only what is required. So there is no method to access to any inner class. It just exposes the business logic. And favor local pooling, right? Because everyone talks with API. If you want to change the implementation, you can do it without much problem. And then we have the MPL, which is like the private part. It provides a highly cohesive way because everything, all the implementation details are inside this module. And I always like to say that it reduces our memory footprint in the sense that If you have just an API and you have several modules, then you need to, all the time think about what is that? What's doing this module? What's doing this module and so on and so forth. So you start, searching which classes does what are the front classes and so on and so forth. So if you have the API, you know that you go to the API, you check the interface, you check the Java doc description and the methods, and you said, okay, now I understand what it's doing this module. And you don't need to, remember all the implementation details, all the classes that you use, and so on and so forth. And of course, you can even, create several teams, and each team can work in each of the modules. It's not, that is something that in microservices you do, that every service is done by a different team, usually. But in Monolith, you can also do it in that way. And the question is how I can assert that there is no violations between modules, so that, for example, the game module does not call an implementation detail of review module. Well, you can use code assert. We're going to see it an example if you are in Java 8 or prior to Java 8, or if you are in Java 9 or beyond, you can use Java 9 modules, right? And of course, this should be used in conjunction with creating the correct scopes on your build tool. So, for example, the MPL module should be added as a runtime module and not as a compile module on any other review or detail module. If you are in the Java 9, then you can just create your module info.java, and you create a module which is called details, which exports the API. So what you're saying is that my package API is exposed, so anyone can reach these packages. But then in the module where you want to use this details information, you just say that you require these details. So in this case, if, for example, game page module tries to reach MPL module, then it will, you will get a compilation error. And this is for isolation. It seems that looks not difficult to do it, and it's just a way of, organizing your monolith correctly. Again, one of the things that we do is just isolation data. With microservices, each service has its own database, so all your model, right, it's isolated inside the service. So can we do this with a monolith? And the reason is, and the answer is yes. We can have just one database, we can have it, and then create one schema for each of the module. So it's not like, okay, I have a schema with all my tables and everything there. It's not in that way. It's like every module has its own schema. Joins only happens inside the schema, not between schemas. So you cannot do something like join game schema dot this table with the review schema dot this other table. You cannot do that kind of things. That of course you can do it, but it's something that if you have a correct code review process, it should be detected there. And you need to really take care if you're using JPA and lazy collections, right? Because at the end you have a collection, and when you do this get to this collection, you execute a join. So you need to take care in these cases. But having it that way, you need to know also that you can use referential integrity across the schemas. If you think about microservices, this does not exist. You have several services, each one with its database, but you have no way to have a referential integrity between all your data. But with the schemas, you can do it. And even you can do something better. These global transactions. This is something that, it seems that if you are doing microservices, you didn't know that exists global transactions. Yes, it's a global transaction every time you see the wall, how it is, not eventually what's going to happen, which I think that's pretty nice, right? So now the question is, okay, you tell me that I have my game module with its schema, review schema and details schema. I have the game review and detail modules, and then I have some .SQLs, right, files there that I need to, populate into the database. So that I think is like how I can do this in a good way, in an easy way. And this is by using Flyway. I don't know if you know Flyway. It's been there for a long time. It's developed by my friend Axel Fontaine. And basically, it's a version control for your databases. So it works something like that. You have a file. This is V1. This means that this SQL is the version 1 of my script. And then when Flyway executes this, it creates 3 tables, for example, and it creates an extra table called schema version, where it stores that the v1 initial SQL script has been executed in this database. So what's happening when I have another SQL, then I want to execute this v2 update.sql. So it's going to happen with Flyway is that it's going to check the schema version. I will say, okay, currently we have the version v1, and I want to populate v1 and v2, but v1 has been already populated, so I'm just going to populate v2. And it happens something like that, that it creates the population, and then it just adds the new table, and of course it updates the schema version that's saying in this database there is the version 2 of your data. So Flyway, well, it offers several ways of running, like for example programmatically with Maven and CLI or Gradle plugins, so it's easy to use. You just put your scripts or your .sql scripts in a directory, and then you just run Flyway, and Flyway will take care of maintaining always your database with the correct version. Another thing that microservice uses is like these reactive extensions, right? It's like if you are in a microservices world, you are using a reactive approach because, well, you are using networks. Network is really slow if you compare it with a method call, which is just memory, right? And then you need to do reactive programming because it's like, okay, I sent a request and then I will wait somewhere, but this thread can still be used. So it's like, like waiting there until this new data comes, and then when it comes, it will be processed somewhere in time. So it's not like I sent a request and I wait. It's like I send a request, I free the resources, and then when the response comes, then I will do something. And this is something that we can still do in Monolith. We can use reactive extensions in your Monolith. In this case, I'm going to show you Reactive Java. With Reactive Java is a library for Java for composing asynchronous and event-based programs. And this is how Reactive Java is a really simple example, but this is, I would say that is the one that I've used in most of the time. The first part, this observable get game, is how you create the stream. You need to create a stream, which is the one who sends data. And you just need to, create the stream with observable.create, and then you just set here that when the gameService.findGameById method returns something, then send it back to the event stream. That's really, notice that in this case, gameService.findGameById is just a query to a database. And then this is the second part, which is like, what do we do when an event is sent to the stream? And in this case, what I'm saying is like, okay, I want to just call getGame, getDetails, getReviews. So I'm saying that I need data from game query, from detail query, and from reviews query. Then I said where I want to run this. Notice that at the very end there are threads, so there should be some threads running this. And if, for example, this is a single thread, it means that it will run first getGame. When getGame provides the data, it will run getDetail. When getDetail receives the data, then it will run getReviews. But in this case, I'm using a pool of threads, so it means that all these methods will be executed in parallel. Then there is an operator that is called zip, which is like, I want to run getGame. That is find game by ID. I want to run find detail by ID. I want to run find reviews by ID. I want to run these 3 queries in parallel, because remember that we cannot do joins between schemas, so I need to run it independently, as you will do with microservices at the end. And then when these 3 calls has the data, just this is like flip it. It means like, mix all of them. And mix in that way. In this thing is like take the game, keep the detail, and take the reviews, and create a new object called GameInfo with this 3 data. And finally, what I want to do is just send this GameInfo to another caller. In this case, is the async response of JAX RS JAX-RS, from Java EE. So, as you can see, you can, if you want to learn reactive programming, you can still do it in a monolith. Let's see more. For example, network. As you know, in microservices, there is a lot of network calls. Network call for service A calls service B, and the service B calls C and D, and so on and so forth. And for this reason, there appear some new patterns. And network is important in microservices, but if you have done monoliths, you know that there is also network. Mail services, JMS, queues, databases, all these operations, there are also a network involved. And it means that we can just use circuit breaker pattern as you usually do in microservices, but in the monolith. And circuit breaker pattern is like, it's like a pattern where you grab a function into a circuit breaker. And if some threshold error is reached, the circuit is tripped. So no further calls return an error automatically, right? So you can see it with this example, which is like the circuit is closed. If I send a request to the network and the network is success, the circuit is still closed. So it means that the request will be proceeded. If it fails, it doesn't matter. I mean, it will continue to be closed. And then I will return an error to the user, but I will update a threshold. So if the threshold reach some default value, then the circuit will be open. And open means that any other request will not be sent to the network. And this is really important because not sending a request to the network means that you are not going to spend time and resources on creating the file description, opening the socket, sending all the protocol to, sending not all the TCP protocol to the network, not to say, yeah, it's working or not, and so on and so far, right? So it's really important. Then, when it's open, after some time, the next request will be retried and said, look, I've been opened for, 10 seconds. Let's try if this next request works. And then it will try it. If it works, it will be closed. If not, it will continue to be open. So this is a really important thing to save resources when there are network communications. And probably most of you will say, I'm waiting for a Hystrix example, right? Because it's the most popular one. But my advice is that do not use Hystrix. And the reason is that Hystrix has a lot of dependencies. And you know what's happened with Java and class path problems, right? So I recommend you that you use Resilient for J, which is pretty nice. It just have one dependency, which is Vavar, and Vavar has no other dependency, so no transitive dependency, so your class path it's really clean. And you just need to define a circuit breaker. In this case, for example, I define a circuit breaker for all my database connections. I wrapped the function. This means that I just said, okay, what is the function that I want to be able to communicate with another service inside this block, this circuit breaker decorate checked supplier, and I'm just saying, just find detail by ID. And finally, I do a recover, which is like, okay, what's happened if the circuit is open? What I can do? Well, in this case, I'm just throwing an empty detail. But in your case, maybe, that in a real case, probably you will have a cache system or maybe providing a default values or whatever. So if the circuit is open, this try optional method is executed. Let's see a demo, an example that I have here, so you can check how this works. I'm going to move it here. Yeah, I know. Let me here. Wait. Okay, now much better. Okay, now this is the project. This is the project, right? We have details, game page reviews, and this is just a Java project. And then I have here game page, we have API and MPL. And then in MPL, I can go to source, main resources. And then I have DB, directory, which is where Flyway takes all the SQL scripts, and then I have one part for the data, one part for updating the foreign keys, and another part for the, it's like the initial creation, right? And then I have here this populate, which is the one that is used for populating data. And here there is the game. The first game is The Secret of Monkey Island. Everyone played The Secret of Monkey Island? Yeah? Okay, I put it here as a review, a review with, let me check, reviews, with a 4. It's from 0 to 5. 4 is okay, maybe 5, 3, 5. Okay. Next one is Monkey Island 2, The LeChuck's Revenge. I really preferred the 2 rather than the 1. What? No, it could be. It's like 0, 5. 5, right? Okay. 5, it's okay. Indiana Jones and the Fate of Atlantis. 4, 5. I don't know, but in all the conferences, everyone says 5 always. Doom. It's the 1, Doom 1. I'll put it, I don't know, a 3, okay? No. What? Also 5, okay. Oh, man. Day of the Tentacle, oh, 5. Day of the Tentacle, 5? Okay. And the last one, Thimbleweed Park. I've not played, so I put it as 0, because I've not played and I cannot judge. But anyone play it? Yeah? 3? But it's not very good. I'm not going to buy it then. Okay, 3. Okay. I put it here, 3. And then I'm just, going here and do a Maven clean package. Maven clean package. Skip this. Don't do that at home. I know that sounds strange, right? That someone who write a book about testing skips the test. Yeah. And then I just can copy this to my Wildfly. And I go to Applications, Wildfly, bin standalone.sh. And yeah, if you see, even this is a, application server where everyone says, yeah, I have an application server. It takes like, I don't know, 1 minute to boot up. Just notice that it's boot up with the application deployed, and it's just pretty fast, right? 5 seconds or so. So yeah, and then I can go here, and I can go to localhost / games1. And you can say that game 1, you set a 5, so you have here a 5, and think that it was the Thimbleweed Park. I know Day of the Tentacle was a 5 as well, and Thimbleweed Park, it was a 3, so you can see that here there is a 3. So it's really nice way to, develop. Then, one thing that that I mentioned before is like, what's happening if I'm not in Java 9, but it's Java 8. This is a Java 8 project. This is really interesting, which is this class, which is called dependency test, which basically, it checks that there is no violation on the calls. And it looks like this. It's really, it might sound really strange, but it's really, if someone explain you, it's easy. Notice this class. I have that one class that is called org, Lord of the Jars, games. This means that I'm referring to my root package, org.lordofthejars.games. This is how you specify the package. And then I have here some fields. One is called game API, game MPL, details API, reviews API. This means that the name of the field is the subpackage. So when I said here game, what I'm saying is that org.lordofthejars.games.game. When I say games API, is org.lordofthejars.games.game.api, and so on so far. And then the only thing that I'm saying here is like, okay, game must use game API, details API, and reviews API. And game MPL might use game and game MPI, right? So if game use game MPL, then this test will fail. So it's an automatic way to have all your quality as a test. So when you run your test, you are also checking that you're not violating any of these rules. So it's a really nice way to, if you are not into Java 9 modules, to use it. And well, and here you just say that something like these are external dependencies, so don't scan it because they are externals, and probably you will find them in several modules. And then you do an analyze, and it analyzes everything, and it's green if everything is fine, and red if not. So let's continue. Let's see if this works. Yeah. Yeah, this is the circuit breaker, the demo, and DevOps, right? With microservices, everyone started doing DevOps, and this is by definition. If you are not using DevOps, then you are not doing microservices. And one of the reasons of DevOps is that you are reducing the time between you have an idea, and this idea goes to production. The idea is to just, reduce this time, ensuring high quality. Usually with Monolith, if you think about your Monolith, it's like, yes, we take like months, right, to deploy my Monolith. And the question is like, why? I mean that if you think that you're going to deploy microservices every day, why you cannot deploy your Monolith every day? So this is a scenario where we get it if you are not into DevOps, where, the developer is the responsible of developing, and then at Friday evening they said, I finished my work, there is the Word file, please ops guy deploy it to production. But I'm going to go to the bar and just enjoy my weekend and have luck in deploying this. The problem is that your code has no business value until it's deployed. I mean that you can say, yeah, I'm going to use a Spring Boot, I'm going to use a Scala, I don't know, any technology that you are really encouraged to use, or I don't know, whatever, but it doesn't matter. At the very end, the important thing is when it's in production. If it's in production and it has adding a value, it doesn't matter if it's a Spring Boot or whatever, or Java EE, it doesn't matter. So the thing is that you need to work hand to hand with ops people, delivering together, and the devs are always there until the component is on production. And you said, yes, we are doing this in my company, and now we have the devs and the ops working together, but we are not still able to deliver every day. And the reason is like this. Because it's not about dev and ops, it's about the whole company. The whole company should embrace DevOps. Everyone should be there until all the work done is on production. And just let me give you one note. Notice there is the DBA, right? I'm not saying that DBAs are zombies. I'm saying that they like Walking Dead. Because, sometimes, some people said, you're saying that I'm a zombie? No. It's like they like Walking Dead. So it's really important to embrace DevOps, to be able to deploy and release every day, and to do it quickly. There is, Docker. Everyone knows what is Docker, so I'm going to skip what is Docker. But what is really awesome about Docker is that you can define the whole stack. I remember I worked in a company like maybe 4 or 5 years ago, and then I worked there, and they said, look, when you finish your job and you do the push and the Jenkins says that everything is green and so on and so forth, it's going to send an email to the ops guy. And this ops guy is going to take your war and deploy it. But please, send him an email with all the instructions on how to deploy this war file. And it was, okay, I'm going to send them an email. And every time that we released a new version, I sent an email to the ops guy, right? And then I moved to another company, and then this company said, look, well, this is how we worked in the past, in my previous company, how you're doing. And said, oh no, we are really smart. We are using a wiki page. And it's like, okay, that's the thing, right? I mean, that a wiki page that is just updated once in his life. So this is what really makes Docker awesome. You define your full stack. You said, I want to use this kernel with this version, this Java virtual machine, this application server. These all are my configurations, like drivers, I don't know, users that are able to run, and so on and so forth. And finally, there is my WAR file. And everything is just, packed inside a container, and then the ops guy just need to do Docker run. And that's all. I mean, from the point of view of deploying something, anyone doesn't need to know anything else, just that they need to use Docker run. The problem, as you may expect, is that how we can scale this, how to avoid port conflicts, manage the host, and so on and so forth. So with Docker, it's really nice, but it's just a Docker host. But probably you will have more than Docker hosts, how you can start and replicate all these containers. And one of the things is like SSH Docker run, then you do SSH to another machine and you do Docker run, and so on and so forth. Right? This is one way of doing it. But of course, the answer is Kubernetes. Probably almost everyone here knows what is Kubernetes, but basically it's a container orchestrator which allows you to do things like that. Like you have a cluster with several machines. Each machine has one thing that is called kubelet, and then this kubelet receives all the job from the master, and then said, look, I want to have 3 instances of my monolith, right? And then it just checks the cluster state and just replicate this your service in 3, in 3 places. And if you said, for example, one of these services is down, then automatically Kubernetes will check it and then will boot up again the service. So it's a really nice way of deploying and maintaining your application up and running, and you can even use it with Monolith. And this is, if you are in the Monolith, or this is how all my Monolith looks like, where you have a load balancer at top, and then I have the same service duplicated, for just in case it goes down. And then usually I had 3 databases replicating the data. This is how my Monolith usually looks like at production. And basically what we did in that way is like, having some scripts, and the scripts boot up everything. That's cool, but does not scale very well, right? Because if you want to add another service, then you need to run it again, this service, and what's happening if the service is down, and so on and so forth. For this reason, it's really interesting Kubernetes. And notice how simple is the Kubernetes file to deploy a monolith. If you are into Kubernetes and you start with microservices, you see very, very long line files, and so on and so forth. With Monolith, it's really easy. I just said, I want 2 replicas, and this is my container, and this is my port, and that's all. And without doing anything else, I will have 2 instances of my service running. So instead of having to run manually scripts like I did before, I can just take Kubernetes to make this work for me. And this is how, that looks in Kubernetes, where I have my reverse proxy. This is the front load balancer, and then I have here those 2 instances of games, and then I've got my database with just 3 instances. In this case, it's a CockroachDB, which is a SQL database that I think that if you have problems with replicating data across SQL clusters, it's a really nice database that solves all these kind of problems. So now there is no excuse to not deploy every day because, we have longer scripts or many more processes. But there's even more. This is like cloud-native applications. And basically what cloud-native applications is that you are able to scale up and down at rapid rate automatically and recover in case of errors, right? So it means that if your application is cloud-native, it means that it boot up really quickly. Also, it goes down really quickly, and it has no state. It's a stateless application. How I did this in Monolith in the past? Well, basically, I use sticky sessions. I know that someone will say, what the hell, sticky sessions, man? Yeah, I know, but we did it in that way. And the thing of a sticky session is that when you get it a request, the front balancer just takes your IP or MAC address and so on and so forth and says, okay, your request will go to the service 2. And then my shopping cart, in case of your shopping cart, is going to be created in the service 2. Then when you add a new element to your shopping cart, since the load balancer knows that your MAC address, IP, and so on and so forth is the same than before, it's going to send the request to the service 2, not to the service 1, because the service 1 does not have your shopping cart. And then what's happening if the service 2 is down? Okay, you've lost all your shopping cart. I know that it sounds strange, but we work in that way. And, well, the truth is that it works. But you can do it better, and it's just following the microservices approach, which is just using an in-memory data grid. And in-memory data grid is just a data structure that resides internally in RAM, and it's distributed among multiple servers, right? So this is something that you need to change of how you design your monolith, and it works like this. When you get a request, it doesn't matter if it goes to service 1 and service 2, because there is a data grid, and it just receives service 1, it adds the shopping cart of user A, and it replicates to the data grid of the service 2. So now if, for example, the service 2 goes down, it doesn't matter, because the service 1 it still contains the data. It's just, easy way to maintain the state. And for example, you can use this really easily with infinite span. One of the things that you've also read a lot is like release as unicorns. It means like, we are releasing once every day. We are testing in production. And you can still test in production and release every day with a monolith. At the end, it's just a simple method of just build your Docker file, build a container, deploy the container. Notice that I said deploy and not release. So I'm deploying to my production cluster, and then I can start testing in production strategies, for example, using blue-green deployment, canary releases, or dark launches. Everyone knows what is dark launches? No? Okay, because maybe it's probably canary release you already know, and blue-green too, because they're the most used. But dark launches are a way to sending real traffic to the new version of your service without the end user noticing it. So the end user will always receive the data from the old version, but you will use his request to also test the new version. This is a dark launch. It's like this. Your end user will never know that you are using him to test a new version. This is used by Facebook heavily. And of course, you can use S2I, OpenShift, Fabricate, Istio. Everyone knows Istio? Yeah, because if not, you need to, the next thing that you need to do on Monday is just go to istio.io and see what is Istio. And if you are into testing in production, I recommend you using Tate and Divisium to be able to manage the state of the databases. So let's wind down. Advantages of Monolith. Everything is a local call. It's really strange, but yes, it's local and always, always works because there is no network involved. All parts are always up. Since it's a monolith, it's just, a jar file, a Word file that is just in the server and it's always up and running. With microservices, maybe you have 20 microservices running and one it's failing. So not all your application is always up and running. With Monolith, always. It's easy to debug. You just, put a debug point and you debug. If you try this in microservices, probably it's not as easy as that. It's really easy to test. You don't need to start doing things like contract testing, service virtualization, and so on and so forth. Refactor without surprises. This is another thing that probably, if you are into microservices, you found is like, okay, I have my service B that communicates with service A, and then someday I decided to change a JSON field from name to full name. And then what's happening? Okay, the service A has not been updated, and then it tries to find the name field, but it's a full name, so it receives a null, an exception, or whatever, right? And with a monolith, you don't have this problem. You just go to your Pojo, you do refactor, and IDE will take care of updating everywhere. You see all the time the real wall. That there are just one transaction. The transactions are global. There are no eventual consistency. It's really easy to deploy. Remember that with microservices, each of the service needs to be deployed independently. But the truth is that if you are into, a real world, sometimes you need to coordinate the release of services. Because if not, maybe you have not think about correctly the first service. So you modified the second service, and then you said, yeah, but the first service needed this. Oh, yes, true. Okay, then we were going to deploy both at the same time or something like that, right? With microservices, with Monolith, you don't have this problem. And finally, you can still use polyglot languages. Well, if you're into the Java, you can use, for example, in your Monolith, you can use Groovy, Kotlin, Java, Scala in the same project. You can do it. I mean, I know that you will not be able to use, for example, Go, but yeah, but you have a good range of languages to be used. And even with DB, if you say, yeah, but I want to use an SQL database and a document database and a graph database, yeah, you can use it. Nobody says here that you cannot use more than one database in a monolith. So, my question now is like, if you are into microservices because you think that you are going to be able to deploy once every day, my question is, if you are not able to release a monolith several times per week, what makes you think that you're going to be able to do it with microservices? Probably not. I mean that easier than a monolith, it's impossible. So if you are not able to do it with a monolith, it's impossible that you're going to do it with microservices. And then it's a good opportunity to learn how to do it. And with Monolith, it's really easy. You just start with reorganization to DevOps, and then you apply DevOps strategies to your Monolith, and then you start with an infrastructure of infrastructure self-service as code. This is like I remember in this company with the wiki page, right? That I said, hey, I need a virtual machine on production with this database. It was a PostgreSQL, and they said, "Okay, yes, fill this, fill this ticket." And then after 2 weeks, I had this database in production to be able to run my test. This is not how it works. If you are not taking 10 seconds to deploy something that you need for your development on your production cluster, then you need to fix it. Automate everything, CI/CD deployments, advanced deployment techniques we've seen, A/B, blue-greens, canary red branches. Apply these techniques to your monolith. And then when you're able to do all these kind of things with your monolith, then jump to microservices, but not before. And also notice that if you apply all the things that I've shown you in this presentation, I mean that I can even show the source code. If you follow this, it's really easy to split the monolith into a microservices. It's really, really easy. If you don't follow these advices, this is you in the near future, right? Yeah, we're going to go to the containers because it's really fun and so on and so forth. Okay, you're going to end up like this. And yeah. But finally, before I end up, I want to show you an example of successful microservices architecture. Who uses a Stack Overflow? Everyone, of course. I always say that when GitHub is down, I cannot stop working because there is no way to push code. Yeah, but it was distributed, right? Yeah, but if GitHub is down, nobody can work. If a Slack is down, happens the same. And if a Stack Overflow is down, it happens the same, right? And yeah, usually it's something, and probably, I mean, I don't know exactly the details of Stack Overflow, but so probably they have a question service, stat service, a question service, user service, advertise service, right? It has more or less this, right? Well, sorry, Stack Overflow is a monolith. It's a monolith. They are serving millions and millions of requests every day, and it's a monolith. So if you said, yeah, we need microservices because we are going to receive thousands and thousands of requests, okay, think about if you're going to receive more or less requests than a Stack Overflow, right? And you said, okay, and now what you're going to show me? Well, I don't know if you see it correctly, but this is a number, and this is the date dot a number. If you go to Stack Overflow, at the bottom of the page, you will see this number. Then go again after 5 minutes and refresh the page. And the number has been increased. So it means that probably they are deploying like maybe 50 times every day. And it's a monolith. 50 times every day. So when they say, yeah, with monolith it's impossible to do this, well, think about in a Stack Overflow. Last thing, and I'm not going to say anything, just read it, and I will go to the last slide. Okay, think about, who is the snake? thank you very much. If you have any question, just here is my Twitter, my email. Yes, you can send me an email, because if not, I will not put it in the slide. So feel free to send me anything, any comment, whatever. Thank you very much. Well, if there is any question, we have 5 minutes. If not, I will be here. So, yeah, happy to chat with all of you. Thank you.